up in Portland at Monodorama. Speaking of Monodorama, we have Mr. Monodorama himself, Jason Dixon, hanging out with us here in Mozilla all afternoon. But one thing I realized when I was at Monodorama is this product I've been working on for a while, piece of software called Heka, which we're using here in production at Mozilla to process data and do anomaly detection, monitoring, et cetera. People haven't really figured out what it is, so I thought it might be time to put together a new talk and try to convey what Heka is, what I've been working on, what we've been working on here in the Cloud Services Department. And this is our first spin of the new approach, so we'll see how it goes. Put a Heka on it, practical applications in stream processing. So as I was saying, telling the Heka story, Joe is one of several folks that I was speaking to up at Monodorama in Portland, talking to them about their applications, what they were doing, what their problems are, what sorts of issues they're having in dealing with the fire hose of data that's being generated with their metrics. And also mentioning, hey, I've been working on this thing called Heka. And a thing that I got from a lot of people was like, yeah, Heka, I've been meaning to try that out. It sounds really interesting, but I haven't had time because I got all these other problems that I'm trying to solve in the meantime. And I was like, well, Heka actually was built to solve that problem, and people weren't getting that. So I realized that the Heka story hasn't been well told, and I'm here now to try to do a better job of telling that. And I would ask people, what is Heka? What do you think it is? And I got a lot of different versions of what people thought it was. It was described as a tool for logging and log processing, sometimes metrics gathering, sometimes for monitoring and notifications. Some people thought it was a real-time graphing tool. Other people thought it was stream processing. That's the one I use most often. But which of these is it? As you might guess, the answer is all of the above. It's a Swiss Army knife sort of a tool, and this is why it's been sort of hard for me to actually get the story across very well, because simple one-use pieces of software are pretty easy to grok and pretty easy to explain in an elevator pitch. Heka is very pluggable, and it's a general purpose pipeline for grabbing data, shipping data, doing stuff with data, watching data, processing data, and then reserializing it and delivering it to other places. It's hard to kind of figure out what it is. By itself, it's a bit of a tabula rasa, an open book, but once you see it in action a few times, you start to get a better idea. And so this is actually going to be a very slide-light presentation, and we're going to spend lots of time looking at live demos, so hopefully the demo gods are with me today. So the Swiss Army knife, this is the Heka architecture. We've got this, I think, well broken down pipeline. We've tried to take some of the ideas that we saw out there in other pieces of software and extend them a little bit based on what are the sweet spots for kind of handling data, sending data through a pipeline in a very generic process. One thing I'll draw your attention to is, you've got inputs and outputs that handle the raw I/O side of talking to the outside world, whether it's interacting with processes or file systems or networks or what have you. And then we have splitters and decoders and encoders that actually handle, those are separate entities that handle the process of, stream of data came in, find a place to slice it, and then turn it into something I can work with, or serialize my data from the inside and send it out. So you don't have the same plugin having to re-implement the TCP protocol with reconnect and queuing to disk and that sort of thing over and over again. We tried to expand that a little bit. This is the Heka architecture. This is the story that I've been telling all along, and this is actually the story that hasn't been working very well. So we're going to actually skip that and go to the important part, which is, what does it do? I know. So who here uses StatsD and or Graphite and or any other kind of numeric stats tool? Raise your hand. Yeah? Fair amount, most. You ever wished your graphs in Graphite updated more quickly than they do? No, never. You ever wish you could do monitoring or anomaly detection or maybe generate some notifications off of those stats really easily? Put a Heka on it. All right, so let's take a look at what we've got here. To the terminal. So we'll start with, moved all of my things to the wrong screen. There we go. Start with a simple Heka config. Got some basic configuration here. There's a TCP input, which is going to be something I use to send control messages into Heka. If this were actual production, we would have used TLS true and actually have some encryption stuff there, but this is all happening on my local machine, so we're not going to do anything with that. And then we've got a sandbox manager filter. Don't worry too much about this. You'll see what these things mean in a second. But basically, this is telling Heka that I can send control messages in over a TCP port, and this guy is going to be listening for those control messages that I send. I've got a signer that's someone on the ops team. An HMAC key means you're on the ops team. And this says this manager filter is going to listen to someone on the ops team. If I've got that key, then I can send messages to this filter. We're going to do some counting. We're going to send some output just to the standard out. There's going to be a dashboard. This is real simple. Look at the statsd stuff here. There's a statsd input, which is going to handle statsd protocol data coming in. There's an accumulator that's going to do the tallying. And then we're actually send data out to Carbon. And you can see here, regular graphite. We're actually going to send it to Carbon. You could write it directly to WhisperDB files. The question was, are you sending it to Carbon or writing it to Whisper? There is a WhisperDB output that'll let you write directly to the file system, but usually we have our Whisper data somewhere else, and we've got existing Carbon infrastructure. So the point I'm trying to make here is you could shut down your standalone statsd, replace it with Heka, have no change in the behavior, and get to start doing additional stuff with the data in Heka as it's happening, and that's what we're going to see. So fire up Heka. It now just started up. It's running, doing some basic testing here. And let's fire up. I have a little statsd traffic generator here. Let's see. Lost my history. So we'll just do like 10 counters, 10 timers, no sets, no gauges. Just fire a bunch of stuff up there. All right. Data flowing through there. Let's take a look at the Heka dashboard. You can see the various plugins that you saw in the config showing up on the dashboard. See the manager filter. You can see the input, statsd, stat accumulation. Come here. Let's take a look at the counter. Oh, there's some data flowing in, graphite, just like you'd expect. 5 minutes, 1 second intervals. Usually that's, in production you use a little bit more than that. So great, statsd. We just did statsd. Lots of people do statsd. That's not particularly impressive. But what we do want to do is a little bit more. So let's take a look at some additional code. Now, Heka is mostly written in Go. You can implement any of the plugins in Go. But if you're going to implement a plugin in Go, you actually have to recompile it into the Heka binary, redeploy. If you want to change the behavior of it, you need to reconfigure it, restart the server. But you can also implement our filters, our decoders, our encoders in Lua. And if you do that, then you can add them to a Heka without having to recompile the binary. And in fact, for the filters, you can even shoot live ones into a running Heka server without the need to even have shell access to the machine or restart it or reconfigure it at all. So that's what I'm going to show off right now. We've give you some nice handy Lua libraries, a circular buffer library to deal with time series data, some anomaly detection library. The circular buffer library will automatically interact with the dashboard and give you streaming graphs, give you annotations on the graphs, give you additional little tools to work with, JSON serialization and deserialization. So what I'm doing here is processing a message, pulling out the timestamp, pulling out a regular statsd value. This may look familiar for anyone who knows the statsd graphite format. And then we're going to add it to a circular buffer. And then every so often, we're going to inject that circular buffer back out into the Heka pipeline. Here's some configuration that goes with that little filter. And this is a command. We give you a little command line utility that will take that code that I just showed you and additional configuration that tells it where's the Heka server and that has that ops key, the ops team key that I told you about in the config, and then shoots it into a running Heka. So let's get the dashboard back up here just so we can see it happen in real time. And we'll run that. Boom, new filter shows up here. Now the counter stats are there. And there we are, real time, every second, updated graphs. Look at the graphite, stats-d, graphite, Heka, graphite, Heka, graphite, Heka. So the important thing here is not just that you can see a graph that matches what graphite would give you, but that you can see this graph updated in real time, and you can add these graphs ad hoc to a running Heka. You can actually extract any sort of data out of any type of data that is flowing through your Heka pipeline. Dynamically start like parsing this data and doing interesting things with it in a Turing-complete, very efficient language. And all of the Lua filters are also sandboxed. They are given a maximum amount of RAM they can use, a maximum amount of CPU cycles that they can use. You can actually have ACLs. The ops team can get 100 sandboxes they can create. The dev team can get 50. Business team can get 25. They can have different levels of how much RAM and memory they can use, or RAM and CPU they can use. And if it overshoots any of that, if I try to do something bad, if I have a bug in my code or I'm a nefarious actor, no big deal. Heka will just shut down your filter, put in a termination report. You can be doing other mission critical things on the same Heka server and not have to worry about any of these blowing up and causing problems. And with the anomaly detection, you can start having annotations show up on the graph, firing out new messages that will send notifications to IRC, SMTP, PagerDuty, what have you, and get notifiers on that. What we usually do is start out with graph annotations and kind of watch them for a while until we're sure that we're not getting more false positives than we want, and then start turning on the live notifiers from it. So that's stats-d. Great. What about Logstash? Anyone here use Logstash? Raise your hand. Logstash with the elk stack is what they're calling it these days, right? Elasticsearch, Logstash, Kibana. Great pieces of software, all of them. Heka stole a lot of really good ideas from Logstash and expanded on them. So I have a lot of respect for Jordan and for the work that they've done there. But it does start a little bit slowly. If you use Logstash, you ever wish it would just start right up? You ever wish it ran a little faster or was light enough to use as a log shipper, or didn't require the JVM? Ever wish it would handle arbitrary rotation schemes and domain file and directory structures and do a better job of actually dealing with the structure of your log files on the servers rather than having to change the way your logs are structured in order to load them into Logstash? If so, then maybe consider the Hex stack. Put a Heka on it. So we'll come here. CD, this Nginx. So here's another piece of TOML, the config format. We've got a log input, log streamer input, that actually knows how to handle kind of arbitrary log formats, log rotation schemes. You give it the information, a regular expression of where all your log files can be found. You can have a directory for each domain, and you tell it, each directory represents a domain, and it'll kind of separate those out into separate streams for you. It doesn't matter if you're like rotating 0.1.2.3 or putting timestamps at the end and adding new ones every time. Whatever you're doing with your files, LogStreamer will handle it. It'll keep track of how far it's advanced in the stream. So if you stop and restart, it'll pick up where it left off. And then we're going to load up some Nginx files. And this is interesting here, the log format. If you're using most log parsing tools, you have these servers that generate log files, they have dynamic formats that they can generate. You usually have to specify in the config file on one side, what is the format that my log is going to be in? And on the other side, you write some regular expressions that consume that format, and you have to kind of make sure that they match up. Well, we've done there's a really great tool in Lua called LPEG, Lua Parsing Expression Generators, and we've done some pretty fancy magic with dynamic grammars so that what you can do for Nginx and for HA proxy and for Apache and for a handful of other servers, you actually go to the Nginx config and you copy out the log format line from your nginx.conf, and then you paste that line into your Heka config, and immediately we'll start consuming that format for you. So you don't have to refigure it dynamically. And that's what this is right here. And then we're going to send the stuff to Elasticsearch, and we're going to use a regular simple JSON encoder to format the Elasticsearch data before it goes out. We could have used a couple of other encoders. There's lots of ways you can extract your data and send it into Elasticsearch. You can change what you're doing on the fly. So let's take a look, actually. We've got var log nginx. You see we've got access log files. Some of them are gzipped. Some of them are not. Doesn't matter. We'll find all of them. We can actually have a let's see. You can actually run a little utility that'll show you, oh, I'm going to look at these log files, and this is the order that I'm going to parse them in. And this is what they're going to do. And if you had like dozens of domains in there, it would show you all of them separately. So you can make sure it's going to do the right thing before you actually fire Heka up. And then the wrong one here. Oh. It's already running. There we are. Come into Kibana, where you can see last time I hit refresh on this page, there wasn't any data in there. Refresh again. We've got 2,400 records that have been parsed. Come down here and see, okay, what's the request URLs? How many bytes were sent? What's the host name or the user agents? What was the return status code? All that stuff pulled out of Nginx in real time. Interestingly enough, the Nginx that's actually serving up Kibana is what is being parsed right now. So every time I hit refresh, we'll see that number go up a little bit. 2,400, 2,500, et cetera. So doing this all as it's going, statsd running at the same time. I stopped and restarted it, so it lost its connection. Still processing statsd, sending that stuff in there. So there's Logstash for you. What about other data? Arbitrary data. Maybe you have some random data that's sitting around that doesn't actually fit into statsd or regular kind of log file formats. Maybe it's just in a file somewhere and you'd like to do something with it. Maybe you have to make an HTTP request in order to get at it. Maybe it's streaming over a network socket. Maybe it's JSON format. Maybe it's XML. Maybe you can write a little script, or you want to use some of your local file system tools to extract data from your server, proc file system, et cetera, to pull operational data about the machines you're running. Put a Heka on it. So I wrote a little tool here, a little simple tool in Go. It's actually going to throw a couple of dice, a couple of six-sided die, add up the total, and then literally in a very raw manner, just stuff that through a TCP socket. Turn it into a string, stuff it through a socket, new line delimited, no big deal. Come back in here. Kill that. Let's activate our little dice here. And I wrote yeah, that is what I wanted. There we are. So this one starts another TCP input, and then it doesn't actually have to do any decoding. The data coming in that the throw dice utility is going to do is just string data with numbers in it. But we are going to tag the messages as they come in. We're just going to add them as a dice type so that we can find them in the router in a little bit. And then we've got some config here that's saying, okay, we're going to start up a filter. It's going to use some Lua code to run it. It's going to match on dice type messages. It's going to preserve the data so it'll survive through a Heka restart. And then this is the code. Again, the circular buffer library. This time we've got 11 slots in our buffer. We're going to take, for the sum from 2 to 12 of the dices. We're going to pull the data out of the payload. We're going to pull out the timestamp. We're going to convert it to a value. We're going to stuff that into our circular buffer. And then we'll also just add some debug information so you can see how that plays out in the dashboard. And then every timer event, we're going to shoot those messages back out into the Heka pipeline. Let's start it up again. Boom, okay. Find our Heka dashboard. Now we can see we've got another TCP output, or another TCP decoder. You can see the data from the dice is flowing through there. And then we'll come back to our little utility here. And this time we're going to do dice counter. What did I call that? Send in the Lua code and the toml. Oh, in the wrong folder. Let's take that. There we are. Now our dice counter shows up. You see it's processing data, rolling through there. It's got a couple of outputs. First one is the value counts. And now we've got real-time data, again, streaming through. This time we've got all of our totals from 2 to 12. And like you might expect, the distribution of 2 and 12 are the least common. We've got kind of the pairs here. So we can pull out 5 and 10, or 5 and 9 maybe match in those lines. We're seeing the distribution that we would expect. Double click to move back to the full scale. We can do logarithmic scales if that helps see the value, or you can do this sort of thing. Again, anomaly detection, annotations on the graphs, anything you want to do with Lua to this data as it's flowing is available to you. You can shut down the filter and restart it, reload it as much as you want. And one other nice little thing that I want to show off is that there was maybe the little debug thing you might remember. That just shows you some JSON that's actually showing up here. And I don't know if you can tell from there, but the timestamp is being updated in real time. And for this is the nice UI, but if you hit raw, all it's doing literally is spitting some JSON onto the file system and serving it up over HTTP. So what you can do with this is ad hoc API endpoints, right? You've got any data coming through, you write some Lua code, pull data from it, and then serialize it into JSON, do whatever you want, and emit it as a new message. The dashboard will start serving that up over HTTP, and then you can start writing other consumers from somewhere as long as they can get at your dashboard, start pulling it in, mixing, remixing, rematching, doing whatever you want with it. So this is what Heka is about, is giving people without without needing to expose them access to the actual file system, as long as you have your data running through Heka and they have the ability to inject these filters, they can start mixing and matching and doing new monitoring, new uses of the data, and even new API endpoints generated from that without needing to be get an ops person involved and without needing to jump through the hoops that most of the tools will make you do for this. It's fast. It can handle, on my laptop, it can get up to like 400,000 messages a second through serialized and routing and counting. We actually haven't really done significant performance enhancing. I'm pretty convinced we could probably improve that by at least 4 or 5 times the throughput if we get some of the memory copies out of there and change our serialization a little bit. Even the graphs here, in the raw format, all it's doing is outputting this data, and the JavaScript is rendering that to the graphs. So you can see any amount of text that you can generate from the Lua code, you can then have served up by the HTTP dashboard. Yeah. Well, on the graph, so the circular buffer library interacts directly with the graphs that are showing up there. There's an annotation library. There's an anomaly detection library that will let you say, this is the algorithm I want to use. This is the column in my circular buffer that I want you to be watching. And this is the threshold, this many standard deviations, this many variations, whatever I want you to fire an event on. What you do with the event can be use also the annotation library, which is on this particular column on the circular buffer, drop an annotation when that event happens. Or you can use the annotation library manually and just say, oh, I was watching something in the code and I saw something happen. 2 of these followed by 1 of those, followed by 3 of those, pop an annotation on, I want to look. Or fire a new notifier message that'll get picked up by the IRC output or by the SMTP output or ... And that's what I got. Thanks so much. Any questions?
Do I have to?
So everyone can hear.
So I'm just kind of curious, and I think a lot of this falls back on my experience working for a distributed systems company like Heroku. I don't know if you've seen my talks about composable systems. And I think it looks like a fantastic service, it's a piece of software. My only reservation would be that it's built as a monolithic service. Mm-hmm. And it feels like there's a lot of overlap with smaller composable services that are already built. So what is it that makes Heka unique, other than just the integration?
I think the integration is, the performance, and this is something that we've gone back and forth on too, right? There's the Unix way, small composable tools that do one thing and do it well and tie them all together. And then, that works well. And then there are, when you have a lot of different tools that, as we examine this space, and we examined what are people doing with their metrics, how are people processing their metrics, what we found is the tools didn't play well together as well as we would like. There are a lot of very disparate tools with disparate designs, disparate performance heuristics and characteristics, and they were being held together with duct tape and baling wire and a lot of kind of ad hoc scripts and a lot of ad hoc ways for things to behave. One of the nice things, what we tried to do is basically have the tool itself embed some of the composability. So all of the pieces that's inside of Heka, each plugin you could almost think of as the basic unit of composability. And then you do get the chance to distribute the behavior across multiple locations, and you get some consistency in how these things are managed. A lot of times our ops people are happy because it's like, oh, I don't need syslog anymore, and I don't need statsd, and I don't need logstash. I just replaced 3 operational services with one service that's actually performing better than those others and gives me a little bit more consistency of management. One thing I didn't mention is that we usually use this in a tiered format. So we'll run a Heka on every edge point node, and that'll be slurping up the log files and maybe doing some initial processing and aggregating. And then we'll have a Heka aggregator, maybe 2 or 3 of them per availability zone or per data center that all of the edge point nodes will be feeding to. And that'll be doing the next level of aggregation. And the circular buffer can also send out deltas to upstream ones. And then we might have a couple of centralized ones that are actually worldwide, global, service-wide. So yes, we know that we walked away from some of the process level composability. We traded it in for some plug-in level composability, and there are some wins we see from that with the integration, the ability to manage it a little bit better, and a lower operational overhead. Oh, sorry, one right here.
Can you elaborate a little more on the buffering logic? You touched on the circular buffer a little bit, because Logstash famously doesn't have the buffers.
Well, so the circular buffer, we have a circular buffer library that we wrote. Most of it's written in C, but it's available in Lua. It's exposed to all of the Lua modules that you can run inside of Heka. And it's basically just built for handling time series data. So anytime, if you've got log file data flowing through there, you've got server performance data flowing through there, and you want to see these real-time graphs, or you want to do kind of time series type operations with it, then the circular buffer library is what you would want to use. We also, while we're talking about buffering, our TCP output, which is what you can use any transport you want. You can use AMQP, you can use NSQ, other types of transports, but we also have a simple TCP output, TCP input, so you can just go from Heka to Heka without needing any additional services. And the TCP output does do disk queuing, and it does have reconnect logic, and it'll let the queue grow on disk, and we'll drain that once the upstream connection comes back. So that sort of thing is in there as well. There was one question that came up way in the back over here.
Time for one more. Thanks for your talk. I remember seeing the first announcements of this at a Go meetup, and so there's a lot of new features.
Great.
I kind of the same questions I had then, which was really about not like why is it more microservice-y, but almost more like why is it not more Kafka-y. I'd love for there to be a little bit more information either in the docs, or maybe you could just talk about how you chain multiple Hekas together, how you know sort of where those ones are in the stream, what you do for availability, where you know you have data loss, where you don't. That's the thing that I don't see often in the docs, and I don't know where to start with.
Yeah, that's not. I've been asked this question before about data availability, reliability, delivery guarantees. Those are things that are on our roadmap. It's been me and one other person working on this, and that hasn't been where we focused our attention right now. If you really want, if this is like data that you can't lose, there's things like Kafka, Storm, NSQ doesn't quite give you that level of guarantee, but if it's data that you absolutely know that you can't lose, then while it's flowing through Heka, you might lose it. What we actually would do in that case, when we deal with data, we want to use Heka's processing, but it's data that we know we can't lose. We round trip through the file system, and we use that as our canonical storage of the data. And then, okay, worst case, Heka's got some buffers inside of it. Messages are flowing through there. If Heka hard crashes, then anything that was in that buffer is going to get lost, right? But if you've got the data on the file system, then, oh, it went down, no problem. Let's go back, set our cursor where we want it to, turn Heka back on, and it picks up where it left off and keeps going. We would like to have sort of thing where we don't act the incoming packet until we write it to an internal disk queue, and then have some definition. We've thought about it a lot of some definition of this data has been processed. It's been officially as pushed into a data store somewhere, or everyone who wants to do something with it has done something with it, and then we'll advance the cursor on the input, because we do actually have, for a single stream, we have order guarantees. It'll get processed and pushed all the way through the pipeline in the order in which it was come in. So we could actually keep track of how far through this have we gotten all of our data processed, and kind of advance through a disk queue and add some availability guarantees that way, where we know when you come back up, anything that was inside of Heka will automatically get restarted. But we haven't tackled the problem yet of actual, a cluster of Hekas working together and nothing is going to get lost. If that's what you want to do, then you would use Heka in combination with something like Kafka or something like Storm to handle the delivery, and then use the file system to make sure you don't lose that. So it's on our roadmap, but untackled problems right now. Yeah, no problem.
You had mentioned earlier about anomaly detection.
Yes.
Could you just clarify or explain what that means? Like, what's the scope of what you're able to do, and is it a configurability to it, or?
So, yes, I can a little bit. On our docs here, our docs are rapidly improving. There's lots of data in there. But under available modules, there's the alerting module, annotation. Here's our anomaly detection module. So first of all of the anomaly detection is done in Lua. So if there's anything that we're not doing out of the box in our module, you can do it. It's Turing complete language. Worst case is you have to pull in some other modules or write some additional code. You may actually have to implement an algorithm, which is what we've done. You can, we have provided, what we've done, basically how this has all grown is that we started processing some data, we hand-rolled some one-off anomaly detection routines, did that once or twice, and we're like, okay, great, let's abstract that out, put that in a module that can then be reused. So we have a rate of change test, we have a Mann-Whitney-Wilcoxon test, we have some detection there. And these are the two algorithms that we give you out of the box so far. They're made to work with the circular buffer library that we have, where we say, okay, here's the buffer, here's the column, this is the algorithm that I want to use, these are the heuristics for that algorithm. You watch that column, and when those heuristics are fired, then send an alert. Or let me know, return something here, and you do something in the Lua code with that. As we develop, my hope is that as more people use this, as more people develop a corpus of these, we can expand this module, and it'll be a lot more plug and play, and there'll be a wider selection of things to do. Thanks so much.